Welcome to Wine Chats with Bildo and Lindalin. My name is Billy Milovanovic, aka Bildo.
And my name's Lindsay Kirkwood, also known as Lindalin.
And this is an offensively funny podcast about drinking wine and chatting life. Hope you enjoy.
Three, two, one, blast off! So fucking corny.
Lindsay is zipping with excitement.
I can't wait.
Hiya.
Hi, Bill. Today it's all about you and your interest.
Yes.
Talking about the universe.
I don't know why. It's funny because Tom my dad is huge on universe stuff. And he's always, there's a saying, there's something like your feet are on the ground, but your head are in the clouds. There's something.
Yeah. I've heard that before, yeah.
But this is kind of semi-unrelated because for years and years I didn't care about any of this stuff. And for some reason just recently I started watching some documentaries and I'm like, oh my God. Like I'm baffled, I'm scared, I'm intrigued, I'm all of the above.
I'm not. No. I'm playing it up. I am a little bit, but I feel like it's so mind-boggling that my little itty-bitty brain can't comprehend, can't dissect, can't absorb the information. Because it's not just like, oh, there's Mars, there's the sun.
No.
It's so mind-boggling.
And that's what I find really fascinating about it. And I guess like with my anxiety, sometimes it helps me to realize how small I really am, like how much all of this is so insignificant. Like here I am worried about, oh my God, am I going to make it on time to Lindsay's house? Is she going to make me sit outside and wait because I'm too early? You know, when really... Like, guys, we are like a tiny little germ on a rock spinning around a gas ball. Anyway, so today's topic obviously is space.
I call it space shit.
Space and unknown universe, all of the above.
Let's have some wine.
Let us drink.
To get us through this fantastic topic. No, it really is. I'm just making fun of you because you're like a space nerd now, which there's nothing wrong with that.
Hey, space nerds.
It's another sad week. Last week we had a farewell to one of our wine sponsors drinking their last wine.
Yes.
Today is the same thing. So this is our last bottle of Malay Estate.
Yeah.
And it's a 2018 Tempranillo. So we're going out with a bang with them because I love Tempranillos.
Going out with a bang. A big bang.
Woo! Oh God.
Who else got it? Come on, guys.
We got it. We didn't laugh, but we got it.
Somebody out there laughed. I could hear them.
They did. Out on which planet were they on, Bill?
Well, exactly.
Who knows?
Good question, Lindsay. Good question. I didn't even go into aliens and outer space life. I honestly didn't have time.
I was going to say we don't have time for that.
And I mean, guys, the things I'll be talking about today, I know we've all heard of like the galaxy, but I know like it's also fascinating to me. Okay.
Look, that was mine.
Oh, I was going to say, I'll take the little one, thanks.
We're recording early today because we have to...
you can have the big one.
Look, I'll drink it. We're heading out to do some content, so it's really early, but it's fine. It's
fine. We're professionals.
I'm Canadian, so it is evening. It's 8:30 at night.
Let's go with that. Cheers. And cheers, Malay Estate.
I know, Tempranillo. I forgot that it's like a rusty color.
I love a good Tempranillo.
I have to admit, the smell doesn't... It doesn't invite me. Is it nice?
That's beautiful. The thing about Tempranillos, guys, because I'm such an expert, Spanish wines, so fruity. So it's like dry and fruity to me.
I don't know what it is. It's smoky to me.
Oh, I like, smoky,
There's something smoky about this.
I get the smokiness as well. It's beautiful.
Yeah.
That's really nice.
I'm trying to see. Okay, so the flavors, earthy and dark cherry characters.
Yeah, I get the dark cherry,
which are blanched with 12 months.
Frank, please.
Frank, you're annoying. That's my dog. No, it doesn't say anything about
smokiness. Right.
But I get smoky. Oh,
yeah.
Don't you hate when your dog barks? Like a crazy dog? He's a great guard dog.
He is a great guard dog. My puppy would just fall asleep straight through whatever it is happening outside.
Yeah, she's cute.
Shall we get into it?
This.
I love that. This is beautiful. A really nice way to send off Malay Estate from, our wine.
100%. Delicious. Okay, so
Lindsay's going to kick it off with the few little fun facts she found.
The only things that I really wanted to talk about, because I'm like, once you start deep diving and Googling, like it's mind-boggling.
Where do you start? Where do you stop? Honestly,
100%.
Yep.
So we were talking about space junk and how crazy it is.
Yes.
So I'm going to talk about space junk.
Go on, Liddy.
So, like pop quiz, do you know what space junk is? I mean, you would with all your research.
I know that there's junk in space.
Yeah.
Is that
space junk?
a good?
Yeah.
But I don't know what it is. Like, where is it? I'm assuming that some of the space junk comes from us launching rockets into space, and then they like lose a bunch of their shit once they're trying to get into space. And so that stuff stays in space.
Yeah.
Some of it might fall back down to Earth.
Well, yeah, they do, yes. And like, it's not McDonald's fry packets. Like, it's not garbage.
Right.
It's like junk.
I would assume that sort of stuff disintegrates in space. I don't know why.
Who knows? So yeah, it's debris from machinery up there, plus the satellites. So they're old satellites as well.
Right.
That once they've completed their mission, the satellites are just left up there because, like, what are they going to do with them? Like,
right. You know? It's hilarious to me that we're like littering Earth and space.
I know, it's crazy. Insane.
Guys.
Even little pieces of paint chips from rocket ships.
Oh.
It's classified as space debris. Oh. And like, if you think of like a penny dropping from a tall building, like a penny can actually fucking do damage. So like, even though like you're thinking of a little piece of paint chip from a rocket ship, like if that's flying down, like it can do damage, right?
Yes. So it can. Watch out for them paint chips.
Oh my God. So that's what it is. Like, debris from rocket ships, satellites, plus satellites themselves. So a lot
I'm just waiting for us to start. Right.
You know, from
whatever's falling apart. I'm just waiting for us to start shooting like junk into space. I asked Henry like why don't we just do that? Because at the moment we're burying it, right?
Junk or actual garbage.
Sorry, garbage. Yeah. Like our rubbish. Because I'm like, why do we bury it? Why can't we just shoot it out there? To be like a black hole problem. But apparently you can't. It's really hard to shoot things into space. It's going to be a riveting episode, you guys. All right, what else you got, Lenny?
I'm just trying to picture junk getting shot up there.
We need Thor.
Yes. So while there are about 2,000 active satellites orbiting Earth at the moment, there's also 3,000 dead ones. So those are like that's part of the space junk. 3,000 dead ones just roaming around up there. There's around 37,000 pieces of space junk bigger than 10 centimeters, which is like the size of a baseball.
Right.
So 37,000 pieces bigger than a baseball.
Yeah.
That's huge.
Yeah.
And millions of smaller ones, like the paint chips and the nuts and bolts and all that stuff. Oh my God, I have something in my eyeball. Is it space junk?
Is it space junk? Yeah. Is it a paint chip? Oh my gosh.
I don't know. It might be an eyelash, but we'll move on because I'm professional. On January 27th of this year, 2 large pieces of Soviet era, I guess something over them, that area, of space junk missed colliding by just 6 meters.
What?
So like 2 pieces of space junk just missed by 6 meters. That's not like 6 meters.
What do you mean they missed? Missed what?
Like they nearly collided.
Oh, right.
Pay attention.
It's really difficult.
Like I am concentrating with something piercing my eyeball.
So what would have happened if they collided?
They would have collided.
And like, would they could have shoot things down?
They could have hurt, like if they collided in Earth. Plus, if they collide at like how fast they're moving, and it's near Earth,
it would be a problem. Right.
Yeah.
Okay. Yeah.
I don't know. I'll send you the article. You can find out. But so did you hear, speaking of things colliding and meteors and all that kind of stuff, you don't watch the news, but did you hear about the meteor that
in Melbourne
fell?
Yes. Yeah. Yes.
Well, it was not really Melbourne, like near
Victoria?
Mackay. No, like Mackay.
Okay, close.
Your facts straight.
So what was that?
So it was the largest space rock recorded in Australia in the last 30 years.
Wow.
Do you know how big it was?
No.
The size of a caravan.
Oh shit. Imagine that fucking falling down.
That was not a paint chip or a nutter bowl. So that's 80,000 kgs.
Right.
Weight.
Oh my God. 80,000. See, this is the thing. This is the thing about space as well, you guys. We can't comprehend these sizes and these weights and these things. It's actually simply impossible for us to comprehend that.
So, because people were like, oh my God, what is that? Is it an alien? Because like some of the footage
of course,
looks like, oh, what is it? Something falling from the sky with a light. So it's likely that it exploded over the outback.
Uh-huh.
I don't know. Mackay was near.
Could have been in the middle of a city. Like seriously, that could have been anywhere. Like the space rocks don't just pick.
I know. There's sirens going on. Maybe it's a meteor falling right now.
Oh, you'd hear the bang.
Yeah. Well, not yet. Anyway, so it likely exploded 29 kilometers. from Earth.
Right.
So that's actually pretty close.
That is very close. That's not far at all.
So, like, no wonder the images. Like, did you see the
videos?
I
didn't.
You didn't even see any of the videos of it falling?
No.
Billy, this is supposed to be your jam, and you didn't even watch it?
No, unless it's being streaming somewhere, I'm not really watching it.
Yeah,
Unless there's a documentary about it on Netflix, I'm not really about it, no. Yeah, interesting. I didn't see any
I can't believe. It was traveling at a velocity of almost 28 kilometers per second.
Wow.
The force of the blast
20 kilometers per second. Like, you guys imagine one, and that's 20 kilometers. That is insane.
I know.
Sorry, go on.
Ready to be exploded even more? Your mind to be exploded?
I am.
The force of the blast was equivalent to exploding 7.2 kilotons of TNT. I don't know what that would be like, but sounds like a lot.
Again, huge. TNT is a bomb, right? It explodes.
No, TNT, like dynamite.
Yeah, dynamite.
Yeah,
bomb.
but I don't know what 7.2 kilotons of TNT
Well, I mean, it's
looks
more
like.
than 1 ton. It's more, a kiloton is like, I don't know, a bazillion tons. Science, guys. Facts. That's seriously insane.
Anywho.
So many people could have died. But space wouldn't care because we're so tiny. We're so insignificant.
Oh, God.
We're so insignificant. Is it my turn yet?
Well, look, I have something about the sun.
On.
Do you want to hear about the sun? And then we can just listen to your riveting facts?
Yes, go on.
Because this actually blew my mind. My 6-year-old child was reading a book about planets the other day. And I was like, I should really learn something.
Yes.
So I started to look through the book.
Yes.
I didn't pay attention to school. Did you know? I had no idea how old the sun was. Now, you know this because I told you.
I was going to say, you told me. I'm going to say somewhere in the 4 billions.
Yeah. So the sun is 4.6 billion years old.
Cannot comprehend.
How?
How can you?
You can't.
Yep.
So that, and I was like, well, how do they know that? So I had to Google about this. So this can be estimated from the ages obtained from radioactive dating of the oldest meteorites. I don't even know what I just said.
What does that even mean?
But
what?
Sure, scientist.
Okay.
Sure. I'll believe you. You wear a lab coat. Whatever. So it's extremely likely that the solar system, i.e. the sun and the planets,
gotcha.
so smart, asteroids as well,
right,
formed as one unit.
Girl.
Like what? Like as in they formed all at the same time? Is that what that means?
Okay. Into my facts. I don't know.
But wait, I don't know.
I really don't know.
One last thing about the sun.
Yeah.
After reading that it's 4.6 billion years old, it's halfway through its lifespan. So in another 5 billion years, it's going to because it's a ball of fire. Right?
We're all going to die.
We are, because all stars burn out, so to speak.
Yes.
Then what are we going to do?
Well, we won't be alive.
No, but
I really doubt if humanity survives that long.
Oh, I know.
I would be very impressed. I mean, we might survive. Yeah. Well, I'm sure we'll combust and then come back in some sort of form.
Something, yeah.
Right. I think we're just going to keep evolving in some form or another. But anyway, okay.
Just think of what was happening down here when the sun was born or created. You know what I mean?
Well, let's talk about it. What is the Big Bang? Here we go.
It's a TV show.
Guys, I researched a lot of this from kids information because I feel kids information is so much easier to actually understand.
100%. Right? Yes.
Because as adults, this is just insanity. I can't. There's lots of big words. Okay.
Is it the UFOs? Rhodey's not recording. I mean, was she recording?
No, she's recording. That's okay. We'll sort that out in a second.
Okay.
I'll edit this out. Beep boop. Oh. The Big Bang. What is the Big Bang? It is how astronomers explain the way the universe began.
Okay.
It is the idea that the universe began as just a single point, then expanded and stretched to grow as large as it is right now.
But what do you mean a single point?
And then it is still stretching.
But what's stretching? More planets are stretching, or the universe?
The universe. Space is stretching. Okay. In 1927, an astronomer named Georges Lemaitre, I'm not saying that right, George, had a big idea. He said that a very long time ago, the universe started as just a single point. He said that the universe stretched and expanded to get as big as it is now, and that it will keep on stretching. It could keep on stretching because it's stretching.
George needs to clarify. When he says a single point, does he mean it started as a single star and then lots of planets and stars were
Nobody
born?
knows. Nobody was there. Yeah. Okay, keep up. 2 years later, so we're in 1929, an astronomer named Edwin Hubble.
Oh, Edwin and George.
Hubble, ever heard that?
Nope, never.
No, Hubble telescope. I think Hubble telescope. Okay. Notice that other galaxies were moving away from us. And that's not all. The farthest galaxies are moving faster than the ones close to us. I don't know.
What is the actual galaxy?
Good question, because that's going to be my next thing.
Oh, good.
Yes. Yes.
Good.
Basically, it means that the universe is still expanding. Okay, so if things were moving apart, it meant that long ago everything had been close together. So this is how these theories are made. Like they're kind of just reversing it back, I guess. Everything that we can see in our universe today, stars, planets, comets, asteroids, they weren't there at the beginning. But where did they come from? So when the universe began, it was just tiny particles mixed with light and energy. Just stay with me. Try and stay with me.
Trying.
It was nothing like what we see now. As everything expanded and took up more space, it cooled down. The tiny particles grouped together, they formed atoms. Then those atoms grouped together over lots of time. Atoms came together to form stars and galaxies. So stars and galaxies came from atoms, okay? Everything grouped together and created what we have now. Mm-hmm. The first stars created bigger atoms and groups of atoms. That led to more stars being born. Mm-hmm. Okay, so everything basically just started flying around together and grouping together.
Right.
Okay, as new stars were being born... at the same time, galaxies were crashing and grouping together. As new stars were being born and dying, then things like asteroids, comets, planets, and black holes formed. Anybody with me still?
Not really.
How long did all of this take? Well, we now know that the universe is 13.8 billion years old.
Okay, so the universe is younger than the sun?
No, that is impossible. The sun is 4.
Oh, you said 13. For some reason, I had 3. I'm like, how is that?
Guys, this is going to be really difficult if we don't know basic maths, okay?
What does 13 look like? And 3.
Do you know what? Now that we know how the Big Bang started, I think we need to go to a break. And
I need to recoup.
Help Lindsay
Can
out.
you show me what number 13 looks and what number 3 looks? Yeah. So now that I know that 13 has a 1 before the 3 and the universe is older than the sun.
What is a galaxy, Lindsay?
I don't know, Billy. This is why, and like I should know, but I don't know. Well, tell me.
I will tell you. The galaxy is a huge collection of gas, dust, and billions of stars in their solar systems, all held together by gravity.
Okay, and like, are there planets in galaxies? Yes. Like all the different galaxies?
Yes.
Okay, and like where's the state border of each galaxy? Like how do we know when one galaxy ends and we go into New South Wales?
Okay, this is how I understand it. But I mean, again, don't take this with a grain of salt, guys. Yeah. Space salt. It's like they're all just like these revolving things, because you know how there's like a lot of gravity and a lot of movement in galaxies. So they all kind of have their own little like spinny thing, right? So there's a little galaxy here, a little galaxy here, a little galaxy here. So they all kind of just converge and hang out, and they can bump into each other, and that's okay.
Okay.
But generally they just hang out with their own people. It's kind of like houses. Just look at them like houses.
That did not clarify.
On Earth. I don't understand. There are many galaxies besides ours.
Oh my God.
There are so many, we can't even count them all.
Oh my God.
The Hubble Space Telescope. So they created this giant ass telescope. Okay, looked at a small patch of space for 12 days and found 10,000 galaxies of all sizes, shapes, and colors. Basically, they took a photo of space far, far away, and they took from this one giant photo, they took like a little like a little patch that they're looking at and zoomed into that.
Yeah.
And in that little patch, they found tens of thousands of galaxies. Galaxies. We live in a galaxy. We're in a galaxy. Yeah. Galaxies. In a tiny little centimeter.
Galaxy.
In a giant picture. So you can imagine how many galaxies.
There would be millions.
Well, I Googled how many galaxies are there. I just wanted to know, like, how many galaxies are there? It is estimated that there are roughly 200 billion galaxies in the observable universe. So just from what we've been able to observe.
See, and this is, like, I'm just going to cut you off right now because, I mean, you can continue after I make my point. This is what I mean. Like, and I think this is why there's people that are obsessed and like devote their lives and careers to this, because like it's never ending.
It is never ending, and
like,
there's so much to learn.
Exactly. Like you constantly learn stuff about that. But then there's people like me where I'm like, it's just so much. It's too much. I can't.
You can't possibly understand. That's what it's just too vast.
And like to picture like us, like the little world, and like what is surrounding.
That's what I'm saying. We feel so important,
crazy.
and we get so bogged down with these tiny little details of our lives. When you really think about it, dude, you are a speck of dust. Let's talk about what a light year is, because you're a speck of dust that is but a moment of time in billions of years. and you're counting your days and your hours and your minutes. Like,
I don't even know what you're saying. What?
But like, but I can't imagine that the Earth is so old.
Yeah.
But the way that we look at time is so significant. Like we live for 80 years and that's huge for us.
Which is
what I
nothing.
mean? That is it's not even a blink.
The universe, no, the galaxy, what's 13 point something billion years?
Universe.
The universe, yes. With billions, 2 billion galaxies in it. See, I learned something, Bill.
Oh, I think that was even wrong. It was 200 billion.
Oh, Jesus
That's what you can't possibly comprehend. Okay?
200 billion.
200 billion.
Galaxies.
Yes. And that's just what we can observe. Yes. Okay, now this is what tripped me out so hard. So you've heard of light years, right? Do you even understand what that means?
Not really. And I've tried to understand it before.
And it's really tricky.
Yeah. No idea.
Okay. This is what they say. When you're looking back at the sun, or
back at the sun, or
when you're looking at the sun, or when you look at planets, at night you can see planets and stars and stuff. What you're looking at is them in the past. Have you ever heard of this concept?
Well, I have, but my brain, I guess.
Because, for example, it takes the sun's light 8 minutes to get to us. So in the morning, when we come over, the sun comes over the crest of the Earth, right?
It happened 8 minutes
8 minutes ago. That's right. Okay.
I get that.
Kind of keep that in mind because it gets bigger than that. For most space objects, we use light years to describe their distance.
Yes.
A light year is the distance light travels in 1 Earth year.
You lost me.
Oh, shit. That's what I said to you. Stay with me.
I can't.
So in 1 Earth year, 365 days, the distance that the light would travel in that 1 year is how we measure distance in space. So if it takes 8 minutes for the light to come from the sun to us, imagine how fast how far planets are. I'm not explaining this right. Like if you turned on the light here, it would take how far would that light go in 365 days?
What light? The light in my ceiling?
Sure.
I don't know.
That's the point. Well, that's how we're measuring light. I know. I'm so sorry. I hope that you're understanding this if you're listening.
Nobody cares,
I know
really.
it's really tricky. Okay, so listen. When we use powerful telescopes to look at distant objects in space, we are actually looking back in time. How can this be? Light travels at a speed of 186,000 miles or 300 kilometers per second.
That's crazy.
This seems really fast, but objects in space are so far away that it takes a lot of time for their light to reach us. The further the object is, the further in the past we see it.
That doesn't even make the further the what?
So if Venus is the sun. Here we go. It gives us an example.
Perfect.
Our sun is the closest star to us.
Yep.
It is about 93 million miles away.
Far.
So the sunlight takes about 8.3 minutes to reach us. This means that we always see the sun as it was about 8.3 minutes ago.
Yeah, I get that.
Okay.
Yeah.
The next closest star to us is about 4.3 light years away. So when we see the star today, we're actually seeing it as it was 4.3 years ago.
Whoa.
Does that make sense?
It does, but it doesn't. Like that.
Yeah.
How is that possible?
Right?
I mean, it makes sense, but how is that possible?
I don't know.
So wait, the next closest star to us besides the sun, in light years, it's 4.3 years ago. Light years. That's what I said. Yeah.
Yes.
How?
So when we're looking at it, it was actually what we're seeing 4 years ago.
That's so weird.
Like because let's say the light turned on 4 years ago and it's taken that long to travel to us.
To get to us. Yeah.
Which is by the
weird.
So which is why recently, and I'm not saying this right, so please Google this yourself, but there's the James Webb telescope. I just recently watched this documentary on the James Webb something.
Okay.
They basically created a telescope that they sent into space and to try and take photos of like the distant universes, right? And that's, I think, when they managed to see the Big Bang. They saw evidence of the Big Bang 13.8 billion years ago because they look so far behind. I don't know. Have to Google it. This is what I'm saying. Like, it's too big for my brain to understand. But there are literally photos. Anyway.
Okay. Is this episode done yet?
Stars are found in a large group called galaxies. A galaxy can have millions or billions of stars.
Okay.
The nearest large galaxy to us, Andromeda, is 2.5 million light years away. So we see it as it was 2.5 million light years ago.
I can't.
We can't. It's too huge. It's too huge.
Do you know what I find fascinating besides all these facts and like how it actually is more importantly, the people that the people that find this stuff out. Because like I can't even comprehend a light year.
Yes.
Let alone these people are understanding and reading what's going on up there.
Yes.
Like that, hands down to those people, because
I can't.
You have to have a special sort of brain to understand what's going on.
To be able to actually receive this information and do something with it. Because I'm receiving
to understand it.
To understand, that's right.
Yeah.
Yeah. And then create this giant thing to say, hey, I'm going to send a telescope into space and it's going to take a photo of the Big Bang 13.8 billion years ago. Like, what?
And I'd be like, dude, you're so late. Like,
dude,
you're not
I can't
going
even work out how my ring light works, let alone like, fucking what? Telescopes. Okay, I wanted to know how many, like, so how far is 1 light year in kilometers? Like, I needed to try and understand, like, what do we actually mean in distance?
But wouldn't it depend on what you're looking at?
No, because the light is still traveling at the same distance, right? Light travels at a certain distance.
Right.
So what they're saying is the distance that the light travels in 1 Earth year, in 365 days, how fast the light travels. Light travels at a certain speed.
Right.
9.461 times 10 by... It's impossible. You can't tell. It's really far away, but 9 trillion kilometers, basically.
Can I just
This is it. This is the, look at it. Like it's the...
I don't want to...
That's...
How do you even read that?
That's what I'm saying.
Do you know what? Fun fact here. Bane, he's 9. Yeah. He's in grade 4. I don't help him with his grade 4 math.
It's impossible.
It's too much for me.
Yeah.
So that just explains... I don't know what I just looked at.
I don't know what I just saw either. Now, the Proxima Centauri at 4.2 light years from Earth is the closest star to our planet other than the sun.
Right.
Okay, so the closest star to us, right?
Yeah.
4.2 light years away.
Yes.
The furthest one.
Oh, so the third. Yeah.
Yep. So Arendelle, located some 28 billion light years away.
How can it be from one extreme to the other? How can the sun be there and then we got 4.3 years, like light years, whatever, 4.3 years away. And then what?
28 billion light years away is the furthest star that we've managed to find. That's what I'm saying.
The furthest. So I thought you were saying that the next one, like the third one.
No. The furthest one, the most far away. Yes.
Okay.
28 point something billion light years away.
I wonder.
So if the light had to travel for 28 billion years at the speed of 9 trillion kilometers
to get to us here on Earth?
Yeah.
Yeah.
That's why they had to build a really big telescope.
Wow.
Now,
are we done?
No. No, we are not.
Can we be done?
Stardust.
Oh, yes. Right? I made up a stardust, apparently. You told me.
It is totally 100% true that nearly all the elements in the human body were made in a star. And many have come from supernovas. So supernova...
Wait. No. Don't go into that yet. So wait, all of us were made...
So the elements that our body is made... You know how there's like... I want to say 42 elements that everything is made from. Like in science, when you look at the like H2O or CO2 or whatever. Right. So you know the chemical elements, right? Yeah. So there's, I want to say 42 of them.
Okay.
And everything is made out of those elements.
Okay.
Right?
Sure.
Well, I mean, what else is it made? Like our body, our material. Anything is made out of these, a combination of these elements, right?
Okay.
These elements, the majority of them came from stars. Like from exploding stars. So supernovas, like an exploding star. We didn't get into supernovas. We don't have time.
So a star explodes and it makes wool?
It creates chemicals. Listen. Nearly all of the elements in the human body were made in a star, and many have come through several supernovas. So several star explosions are in your body, babe.
I don't get it. What does Jesus think about all this?
Jesus is a story for bedtime. Okay? We are not doing that here. Okay? Listen, the first generation of stars, way back when.
Okay, yes.
Formed as lumps of gas that drew together and eventually began to combust. Okay, so these stars grew, exploded.
That's what's going to happen to the sun in 5 billion years. Yes. I'm so smart.
This would cause a nuclear reaction in the center of a star. Okay, the first stars that formed after the Big Bang were greater than 50 times the size of our sun.
Okay.
Inside stars, a process takes place called whatever the fuck, because we really can't pronounce that word. Basically, the making of elements. Okay, the first stars that burned their fuel quickly were also able to make only a few elements heavier than hydrogen and helium.
Billy, can you go
Basically,
to your next
the first few
fact?
stars created like lighter elements.
Okay.
Like helium, because helium is, that stuff that makes you talk funny. That's right.
Hey, Billy, is this episode over yet? Because I'm bored.
Then the next generation of stars created heavier elements such as carbon and magnesium. Okay, and then basically it kept creating until they created like
I'm listening intently.
Earth and bodies and stuff. Okay?
Yes.
So most of the elements in our bodies were formed in stars over the course of billions of years and multiple star lifetimes.
Okay. Good to know.
I was just trying to explain to you what stardust is, but it's obviously a really tricky thing to explain.
You lost me saying
essentially stars, like when they burst, they like burst, right? And all this bursting because the star, like the galaxy is expanding, like the dust kind of falls onto our Earth and like creates stuff.
Don't understand how that is possible, but sure. If Google said
possible. Okay, you know what? I was going to go into what black holes are, but it's really tricky. And they're just basically giant
I got two
voids in. Oh my God. Giant voids in the universe that suck things in.
3 children. The other one.
Here are some fun facts for kids,
fun
okay?
facts for Lindsay. Yes.
Let's just wrap it up with some actual like fun facts we can consume.
Let's go.
Space is completely silent.
Yes.
Okay. There is no atmosphere in space, which means that sound has no medium or way to travel or be heard.
Right.
So it would be completely silent in space.
Yeah. Well, that's it. That's the way it is in all the movies. So it must be true.
True. Yeah. There's no music playing. It's so weird. Yeah.
Or noise. Yes. Birds chirping.
Right.
Like
no birds chirping. Yeah. Oh.
Yeah. Okay.
The hottest planet in our solar system is 450 degrees. Want to have a good guess what planet is really hot in our solar system? The hottest planet. Just give it
the one I'm on.
No, you are not making Earth 450 degrees. Venus.
Cool.
It's not the closest. Obviously, Mercury is the closest, but Venus has some other stuff going on. How much would a full NASA spacesuit cost, Linny?
A lot. I'm going to say like $1.7 million. How
about 12?
Wow.
12 million. And 70% of that cost is for the backpack and control module.
Wow. I mean, when I say 1.7, that's really stupid of me, really. 12 million.
The spacesuits that NASA uses were built in 1974. If these were priced by today's pricing, they would cost an estimated $150 million.
Holy Okay, that's actually impressive that the suits that they're currently using were made in 74 and
you
they're
still have improved.
No, but I'm saying like they made them really good.
That's surely maybe they've got maybe now they have
add-ons and stuff.
Yeah, like Spotify or something. I don't know. You can be listening to wine chats up in space. Okay, the sun's mass takes up 99.86% of the solar system. I don't understand how that makes sense.
In our
the sun accounts for 99.86% of the mass in our solar system, with a mass of around 330,000 times that of Earth.
Lost me.
Yeah. Okay. 1 million Earths can fit inside the sun.
Wow.
Shit. Sorry.
Whoa. Now I like facts like this. Okay, so 1 million Earths can fit inside the sun. That's crazy because
this is again how tiny we are, you guys.
And that's one fact I did know, that the sun was huge.
Yeah.
But that is crazy.
You can't comprehend that. 1 million Earths.
No, I can comprehend that one. That fact I can comprehend. That's crazy.
Yeah, okay.
But I didn't know the sun was that much bigger.
Now, this is what I didn't know, and I wonder if this would still be true considering how hideous we are as humans. But there are more trees on Earth than stars in the Milky Way.
Oh, I don't know if I believe. What
I don't know
date
if I
is that?
believe
1902?
No, that's what I said, right? There are about 3 trillion trees on planet Earth and between 100 and 400 billion stars approximately in the galaxy. Okay. Oh, this one's a fun one. I like this one. The sunset on Mars appears blue.
I didn't know Mars had a sunset. I mean, you wouldn't think of it. I mean, obviously when you think of it, but
it's not something I'd ever think about. Yeah.
Right,
just as colors are made more dramatic in sunsets on Earth, sunsets on Mars, according to NASA, would appear bluish to human observers watching from the red planet. Fine dust makes the blue near the sun's part of the sky much more visible.
Okay.
While normal daylight makes the red planet's familiar rusty dust color the most perceptible of whatever. Anyway, it's blue.
Cool.
There are more stars in the universe than grains of sand on Earth.
That's no.
See that this isn't crazy. This is more stars in the universe, not the galaxy.
Same thing to me.
Well, it's not because a galaxy
to me is it's the same. I know there's a gazillion galaxies. I know. So wait, what's the mother lode? Is the universe the mother lode of everything?
The universe is the whole shebang.
Of everything.
Yes, like the whole thing.
Exactly.
Yes.
Okay. Yes.
And galaxy, like the Milky Way, that's all like in the one.
Yes. And there's a gazillion galaxies.
200 billion or so.
So many.
Yeah.
Are we
couple
done?
more. One day on Venus is longer than 1 year. So it obviously spins really slowly. Venus has a slow axis rotation.
There you go.
And last one, there is a planet made of diamonds.
Cute.
Right? There is a planet made of diamonds twice the size of Earth. The super Earth, aka the 55 Canceri, is most likely covered in graphite and diamond. Paying a visit to that planet would probably pay for the $12 million spacesuit needed to get there. Oh, cute. So that's that. That's about all the confusion I'm willing to bestow upon you for the moment. And I'm so sorry. I hope that you stuck around for this whole episode. I know it was a tricky one. I know it's not an easy one to listen to. I know it wasn't an easy one to try and explain. Hope you enjoyed. And, just
look.
Remember how insignificant you are, really. If you ever just feel really worried about your life, look up in the sky and remember that you are just floating amongst space junk. That's it. That's my Lord. You are enough. Thank you for joining us for this latest episode of Wine Chats podcast with Bildo and Lindalin. You can find us on our socials on Instagram, Facebook, and TikTok, and you can listen to us on any favorite podcasting app or watch on YouTube.
And don't forget to like, subscribe, share, review, comment, send us some love. We absolutely love it.
Chat soon. Come on, Lenny. Chat soon.
Chat soon.
Chat soon.
We're not putting this in.
Come on.
Okay, we'll add in chat soon at the end. Both of us?
Yeah, go
on. Chat soon.